This time we are going to do decimal to binary conversion. Decimal to binary conversion. Okay, sorry. So these are decimal numbers. Let's say, for instance, 192, 168, 10.10. Okay? These are the decimal numbers. This is an example of an IP address. So we can try to convert this to binary. How do we do this? In the theory class, there was a flow chart that was shown, so you can use any way, because I think in senior school, some used to use this kind of long division, that long division method. So whichever way works is your best method. Okay, but I want to use that flow chart scenario. Okay? First, we start with this 128. We convert it to binary. Okay? So now, let's put our positional notations. Okay? First, we have 128. We have 64, 32, 16, 8, 4, 2, 1. Am I right? We have these positional notations. So first we start with this. For instance, this is n. Is equals to 192. Take this as n. So the formula will be n greater than or equals to 128. Okay? If yes, if this condition is true, you add 1 here. If the condition is false, we put a 0. Okay? So now let's test the condition. Is 192 greater than or equals to 128? 128, that is true, yes. So we put a 1 here. And then what do we do? 192 minus 128. Help us. Okay? My math is not good. Then you have 4 and then 6, 0. So you have 64. Right. So now we use 64 in n. Now 64 is going to go to n. We test the condition. Is 64 greater than or equals to? Is this time? Move into this. Is 64 equals to or greater than this? Yes. We put a 1 here. And then we have 64 minus 64 is 0, 0. Now everything is going to be 0. Okay? So the binary representation of 192, everything is 0. It's going to be 1, 1, 2, 3, 4, 5, 6, 7, 8. This is it. So we can move to the next one. Okay? The same procedure. N is equals to 168. Okay? So this time again, we start. Let's run this one. This is 128. Is 168 greater than or equals to 128? Yes. So we put a 1 here. And then 168 minus 128. This is 0, 4, 0. So that is 40, right? So now we move this to 64. We are moving here. So is 40 greater than or equals to 64? The condition is no. So we put a 0 here. Okay? And move this. Here is going to be 32 now. We are moving here. Is 40 greater than or equals to 32? Yes, 40 is greater than. So we put a 1 here and then put a 32 here, subtracted. That is going to give you 8. So now we move to 16. Is 8 greater than or equals to 16? No. Put a 0 here and then we move this to 8. Is 8 greater than or equals to 8? Yes. So put a 1 here. Now 8 minus 8 is 0. So the rest is going to be 0. Okay? So the binary representation of 168 is going to be 1 0 1 0 1 0 0, right? So that is it. So I think we can move on to 10. Okay. Let's use 10 now. Let's go to 10. Now our 10 is going to be equals to n. We start with the first, the most significant bit, that's 128. Right. Is 10 greater than or equals to 128? No. Put a 0 here. And then we move to the next one, 64. Is 10 greater than or equals to 64? No. We move to 32. Is 10 greater than or equals to 32? No. We move to 16. Is 10 greater than or equals to 16? No. We move to 8. Is 10 greater than or equals to 8? Yes. We put a 1. And then we subtract 8 here. That is going to give you 2. Is 2 greater than or equals to 4? No. Then we move to the next one, 2. Is 2 greater than or equals to 2? Yes. So, done. So, the binary representation of 10 is 0, 0, 0, 0, 0, 1, 0. Sorry?
It's 4 zeros.
4 zeros, huh? Okay. And then 1, right? 0, 1, 0.
Yep.
So the next one is also 10, so it's the same thing. Guys. I know it's not quite easy, but if you practice, you'll be able to do it. So that's good.